Alright, welcome back to Master's Paid Video Tutorial. And wow, today is a wonderful day. Today is 24th December, which is a big celebration for every Christian across the world. Alright, I wish you all a Merry Christmas and a Happy New Year in advance. Very good. That is, we are entering into the year of 2021. But as usual, we are still telling you the course trigonometry, and where are we? Oh wow! Verifying trigonometric identities. Verifying trigonometric identities, and by the end of this whole topic, you should be able to verify identities by working with one side, okay, and also verifying identities by working with both sides. So we are going to go by one side, then later we go by both sides. In fact, it's going to be interesting. All right, very good. Okay, you must also recall that an identity is an equation that is satisfied for all meaningful replacement of the variable. All meaningful replacement of the variable. Now, one of the skills required for more advanced work in mathematics, especially in calculus, yeah, especially in fact, I love calculus, so I keep laughing. I keep smiling when I hear the word calculus. But I love it. And we have the tutorials on that on our video on our YouTube channel. The calculus one, that is the differential calculus, and the integral calculus. Very good. So one of the skills required for more advanced work in mathematics, especially in calculus, is the ability to use identities to write expressions in alternative forms. To write expressions in alternative form. Now, we develop these skills by using the fundamental identities. Yes! In fact, up to now, I'm sure, please, if it's not open, go back and revise. Okay, make sure you have all the fundamental identities open. All the fundamental identities open. Alright, so we are going to develop these skills by using the fundamental identities to verify that a trigonometric equation is an identity of the variable for which it is defined. Of the variable for which it is defined. Very good. So before we start, let me give you some hints to develop, or let me give you some hints to help you get started. Alright. And let me project that for you. Make sure you pause the video and write them all the hints. Alright. Write all the hints, and later you will come back to discuss some more examples. Thank you. Alright, welcome back. So that is the hint for verifying identities. Let me wrap up on it. The first one is that you have to learn the fundamental identities given in the last session. That is the one that we did in our previous videos. Alright. So you have to learn the fundamental identities. I hope you know all the fundamental identities. Let me help you. Some people have forgotten it. The first one is the reciprocal identities. Secondly, we have the Pythagorean identities, the quotient identities, and the negative angle identity. Not all that needed here, but these three: the quotient, the reciprocal, and the Pythagorean. We are going to use it. All right, very good. So whenever you see either side of a fundamental identity, the other side should come to mind. The other side should come to mind. So what if, or what is the case if it's not okay? How is it going to come to mind? It's going to be something else. Alright. So also be aware of the equivalent forms of the fundamental identities. Be aware of the equivalent form of the fundamental identities. For example, the moment you see, let's say, 1 minus cos square theta, know that the other side is going to be sin square theta. Sin square theta. Alright. So we are saying this is an alternative form of sin square theta plus cos square theta, which is equal to 1. Very good. Secondly, 2. Now try to rewrite the more when the question is given to you. That is going for the second part. You have to try to rewrite the more complicated side. The more complicated side of the equation. To that, it is identical to the simpler side. Alright? So all that you are saying is that the one which are complicated is the reciprocal identities. That is the sec, the cot, the cosecant, and all that. Very good. But if you have it in terms of sine and cos, that is not complicated, alright? Because you can rather express tan to sine and cos easily, cosec to sine and cos, sec to sine and cos, cot to sine and cos. But for you to express sine to cosec, to be easy, it will be more complicated for you. Alright, so that is what we are talking about here. And when we are solving the question, you will get to know it. Thirdly, it is sometimes helpful to express all trigonometric functions in the equation in terms of sine and cosine, and then simplify the results. And that is exactly what I just said. You are simplifying all, or let me say you are expressing all in terms of sine and cosine. So you don't need to start from where you have it in terms of sine and cosine already, but rather where you have it in terms of other identities, all right, or other functions. Very good, very good. 4. Usually, any factorizing. Usually, any factoring or indicated algebraic operations should be performed. For example, the expression like sin square x plus 4 square x plus 1. Alright, this is okay. Sin square x plus sin x plus 1. Now, this is in the form of a quadratic equation whereby if you put x sin x to be equal to y, we are going to get y squared plus y plus 1. And this can be performed by factorizing it. Alright? So you can use the idea of factorization to do this. Very good. We are saying that this can be factored as, so you can see this can be factored as Sin x plus 1 all square. Sin x plus 1 all square. Very good. So that is that. You can get the factorized form. It's actually, you can even point to the calculator and see it. Very good. So now, the sum or difference of two trigonometric expressions such as 1 over cos theta plus 1 over sine theta. In case you get something in this form, that is the sum or difference, that means here can be plus or minus of two trigonometric expressions such as this, can be added or subtracted in the same way as any other rational expression. Like if you have, let's say, a over b plus c over d, the only way to go about it is to find the LCM, which is b. Then you continue like that. In the same way, when you are performing such function, or when you are performing such expression, you need to go by LCM. Then that is all for that. Very good. So we are saying that we can use LCM to compute what we have, or to express what we have there. So you can see that the LCM is going to be sin theta cos theta, alright? Now this will cancel this, and this will multiply this. So we get sin theta here plus cos theta here. Okay? And now with this, you can see that this is not 1. The numerator is not 1. Sine square plus cos square gives 1, but not sine plus cos. This don't give 1. Alright? Very good. Now with this, we can even rewrite it in the form sine theta over sine theta cos theta. Because we can split. If you can split a plus b over bd over cd, then we can split this. This will be a over cd plus b over cd. Alright, in fact, if you don't understand what I'm doing, you will say, oh, Prof, let's continue to solve more questions. Let's continue to solve questions. Yeah, we will go and solve questions and you will be fed up on it. But we need to get the concept first. Alright, very good. So we can split this, and here we can get cos theta over sine theta cos theta. Very good. So that one too can work there. And this is the same as what we have here. Alright, point 5. As you select substitutions, keep in mind the side you are not changing. What are these means? Alright, but do you know that all this is because it represents your goal? Because that is going to represent what? Your goal. Let's look at this example. For instance, if you are given tan x plus 1, and we are to prove that it is the same as cos square x, 1 over cos square x. Now we are saying that we pick the complicated part. That means that you not pick this. This one is not complicated. It's in terms of cos. It's not complicated. But this is the complicated part. We can express tan to get sine and cos in it. Very good. So here we keep the right hand side to express or to simplify the left hand side. Now, if you are solving this, it means that if you are expressing this or if you are simplifying this, it means that the right hand side, which is 1 over cos square x, is your goal. That is where you want to be. And that is your goal. Alright. So always keep that in mind. Never ever forget that part. All right, very good. In fact, you have to try to think of an identity that relates tan s to cos s. In this case, since sec x is equal to 1 over cos s and sec square s is equal to tan square plus 1. The second function is the best link, alright, is the best link between the two sides. Between the two sides. In fact, I won't like to solve it. We will look at it in our next video. Sorry, in this video when we are solving the questions. Last one. If an expression, wow, I love these stuff. Merry Christmas. Yeah, I'm enjoying my Christmas with trigonometry. Today is 24th December and I'm enjoying my Christmas with trigonometry. I love that. But I love to teach. Alright, very good. To impart knowledge is something that each and everyone needs to go by. Alright, 6. The question, point 6. If an expression contains 1 plus sine x, if an expression contains 1 plus sine x, multiply both numerator and denominator by, it's like you want to rationalize it. It's an idea of a rationalization. If you have 1 plus square root of s, we can rationalize it by multiplying it by 1 minus, so you take the sign, 1 minus square root of s over 1 minus square root of s. Alright, in the same way, if you have this in your expression, you can multiply it by 1 minus sine s over 1 minus sine s. Very good. In fact, you don't change anything. It's not changing anything. Just cancel this, alright? Because multiply 1 by this function, it's still the same thing. Very good. That is mathematics for you. Alright, and when you do that, you can see that this is going to be a difference of 2 square on this side. There's going to be a difference of 2 square here. So the reason why we are doing that is not that we are doing that because we have to do that. We are doing that because it's going to help us work something. If you rationalize it by changing the sign, you are going to get 1 plus sine x multiply 1 minus sine x. All this over 1 minus sine x. And this is difference of 2 square. That is 1 square minus sine square x. And the whole of it is 1 minus sine x. Hope you can see that. Very good. And 1 square is the same as 1. And 1 minus sine square is a trigonometric identity. Or let me say it's a fundamental identity. And that is a Pythagorean identity. And this is the same as cos square x. I hope this is interesting. Very good. So it's not only so you can see that once you change it to cos square, everything will become easy for you. Alright, similarly, you can do the same thing for 1 minus sine x and also 1 plus cos x and lastly 1 minus cos x may be useful. So for all these expressions, this idea is going to be useful. Oh, we are still not. In fact, I'm sure somebody will say, oh, questions. I'm coming. Let me give you this caution. All right, caution. If you go to the drugstore to buy a medicine, and and the doctors there say that please take your time. Let me give you this caution. This medicine, take it once a day. Alright, you have to make sure that you go accordingly to that. If you go beyond that, challenge, you may not find yourself to be well as you are expecting. Alright, very good. So for you to go go through this course, most especially verifying trigonometric identity, you have to take note of this caution. All right. Now, the caution is that verifying identities is not the same as solving equations. In fact, we haven't solved equation yet. We will go to that part. But before that, let me, in case you have heard something, in fact, because you have influence, let me see, you have influenced some before in solving equations in your high school, alright? So you have small knowledge there. But please, don't quickly jump into that for what you're going to do. Verifying identities is not the same as solving equations, alright? The technique used in solving equations, such as adding the same terms to both sides or multiplying both sides by the same term, should not be used when working with identities, since you are starting with a statement, all right, that is to be verified. So that may not be true, all right, that may not be true for you. So let's quickly come back and start solving questions. So we are going to start by verifying identities. We are going to start by working with one side, all right? By working with one side. Then later on, we move to both sides, all right? So let's look at that. Now you have to know that to avoid temptation to use algebraic properties of equations to verify identities, you have to work only one side and rewrite it to match the other side, all right? Let's look at about 4 or 5 questions on working on one side. Alright, so we look at our first example. Verify that, yeah, you to verify. Oh, we are going to do it together. Verify that the following equation is an identity. Is an identity. Is an identity. Very good. Is an identity. Oh wow. Nice question to be. Always don't be in a rush, okay? Make sure that, in fact, if you don't have the fundamentals, go back and watch. So, solution. Alright. So we used the fundamental identity. From now, we wrote about six rules. Alright, 6 rules. So if I say section 1 or point 1, I mean I'm referencing to that. I'll be referencing those hints. Alright, very good. So we are going to use the fundamental identities from the point 1 to rewrite one side of the equation so that it is identical to it's going to be identical to the other side. Also, since the right side is more complicated, since the right hand side is in terms of cosec and cos sine, but yet, even though we have cos here, but yet still, the right hand side is more complicated. So we are going to work with it. We are going to work with the right hand side using the third hint. Alright? Very good. That is the point 3 in the hint. To change all the functions to sine or cosine. Very good. So we move on. So from the right hand side, cosec is not always theta and x, but here the argument is s. Cosec. Oh. Cosec, we know from a reciprocal identity that cosec s but cosec s is 1 over sine s. Very good. So we know that for cosec. So by substitution, we are going to get 1 over sine s multiplying the inside, which is cos s plus sine x. And now we can go and multiply this throughout. So multiply, now don't forget. When you are expressing and simplifying this, make sure your goal is the left hand side. Let it be in mind. So multiply it by this to get cos x over sine s plus sine s over sine x. Nice. Nice. Now you can see that this is cos s over here quickly. You have to know the reciprocal identities. Here but cos s over sine x is equal to, that is cos. So this is going to give us cos s. Alright. And this cancels this 1 1. So we get cos s plus 1. Oh! The same thing. The same thing. Alright. Therefore, we can conclude that the given equation is an identity, saying the right hand side equal to the left hand side. So you can conclude. Right? Conclusion. Saying the left hand side is the same as the right hand side. We can say that it's an identity. Very good. Let's move on to the second question. Nice. So we go for the second question. And that is tan square s 1 plus cos square s is equal to wow. So now I would like to ask you, which of the side is more complicated? Which of the side is more complicated? So you can clearly see that here the left hand side is going to be more complicated. Alright, so we work with the more complicated left hand side as suggested in the section or as suggested in the second hint or the point 2 in the hint. So we move on as such. So from the left hand side, recoats. Now, it is important to note here that, watch, the argument is S. The argument is not this. The argument for tan is this, X, not this. Very good. So, after writing this, then we are going to what? Okay, you can first distribute, alright? You can first use a distributive property, or let me say, you can first expand to remove the bracket before you start to do whatever you want to do. So let's go for that. So this we get tan square S plus tan square S times cos square S. Very good. Very good. Now, from what we have, always check where we want to go. So, tan square X plus tan square S. Here is cos square. And we know that cos X is equal to, that is the reciprocal of tan. So, firstly, it is the same as cos over sine. But if you want to get it in terms of tan, it will be 1 over tan. And the reason why we are doing it as such is because we want it to come and clear all this. So to get cos square x, it will be 1 over tan square x. So this we get. So this we get tan square x plus tan square x. I want to take my time so that we get a concept. And this will be 1 over tan square x. Very good. And you can see this cancel this. So we get tan square x plus 1. But we are still not there. You can see that. We are still not there. Then, what can we do again? Since we are still not here. Okay. Watch. From one of the identities, this is one side of one of the identity in Pythagorean. And what is that? Sec. Very good. So we know that but sec square x equals to 1 plus tan square x. And that other side is here. Therefore, we get sec square x. You will see how I'm taking my time. Very good. Now, having this. Okay. We want to get this. That is our goal. So, this that I don't want to bring it close to you. This that we have here is the same as 1 over cos square x. Beautiful! Because from our goal, it's in the form of a fraction. So for you to get a fraction, that is the reciprocal form. And now, but cos square x is the same as 1 minus sin square x. Therefore, Merry Christmas. Alright. Therefore, we can conclude it's not there for Merry Christmas. Therefore, we can conclude that 1 over, because we know this to be this side. So 1 minus sin square x. Very good. And that is for that. So see the left side Since the left side is identical to the right side, the given equation is an identity. The given equation is an identity. Oh, I love this stuff. Very good. Let's move on to the next example. All right. Since you are now writing the text, I'm doing it. Three. Tan T. Tan T minus cot T. This is the argument. Like, I don't want to bring that. But that is the argument. Sin T cos T is equal to s squared T minus cosec T. When most students see a question like this, then they begin to panic. Oh, what is this? What is this? Please, don't panic. It's just simple. Alright, very good. So, we are going to go through together. We are going to go through together. So now, which side is more complicated? That's the first question to ask. That's the first question to ask yourself. Which one is more complicated? Oh, left hand side. So let's put from the left hand side. Tan T minus cot T over sin T minus no sin times cos T. Very good. So, I hope you haven't forgotten it. Know that A plus B over CD can be A over CD plus B over CD. Therefore, we can write this as, therefore this is the same as tan T over sin T times cos T minus cot T over sin T cos T. Nice. Now, we are going to do something. Okay. You know that if you have, if not, do you know that? You know that A over B is the same as A times 1 over B. True. Alright. Then we can rewrite this in this form. Okay? And that is going to be tan T will multiply 1 over sin T cos T minus cot T times that cos or cos. And we know from our reciprocal identity that tan T is the same as sin T over cos T. multiplying by 1 over. By now, we should be able to know the reason why we are doing all this. So you can see that. So now, this, you get centimeters. You can see that now, this will cancel this. Hope you can see that. Minus. Now, cos is cos t over sin t. I have all day in my head. All the reciprocal identities in fact, all the fundamental identities. That's why, in fact, you have to go for it. You have to go for it. Go and change it. You have to change mathematics. You don't need mathematics to chase you. So now, this clear of this clear of this. So we get 1 over cos t times cos t. We get cos square t minus 1 over sin times multiplying sin. You get sin square t. How we can see that? Very good. Our goal is to achieve this. Oh, we are almost there. Because we know that 1 over cos square t is sin square t minus this is cosec square t. Beautiful. So we can now conclude that now you can see also that, let me give you this before we conclude. Okay, now you can see also that the third hint about writing all trigonometric functions in terms of sine and cosine was used in the third line, and that is this part was used in this part of the solution. In fact, there are a lot of alternative ways in getting the identity to be equal to this. Someone can choose another method by not first dividing this by this, that by that, and he can also, or he or she can also reach the identity that we are looking for. So, no matter the alternative way that you go, but make sure that it is in hand with, all the 6 hints. Okay, because you can't go beyond that. Very good. So that is that for that. So since the left hand side is the same as the right hand side, or since the right hand side is the same as the left hand side, you can say that the equation is an identity. Very good. 4th question. So on one side. Three or four. 4 and 4. Cos s over 1 minus sin s is equal to 1 minus sin s. 1 plus over cos s. Very good. Now it's too much time. Let's move on. Now, you can see that with this, you can work on the right side. We can work on the right side. In fact, somebody can even choose to work from the left side. okay, it will still work. Now, it is by using the last hint, okay, and the idea to go by is by using the last hint, that is the point 6 from the hint, and that is going to help you to do this. So you can choose to take the left hand side or choose to take the right hand side. It's just that you know how to do your rationalization. So now from the okay. So let's take it, you can choose here or here. Because now, in fact, this in terms of science, because I just want to use in terms of science, so you can use any of it. So from the right hand side, 1 plus sine s over cos s. So with this, we use the point 6 from the hint to say that we have to rationalize this. And it is by multiplying this by 1 minus sine x over 1 minus sine x. So you can see this is 1. So it's the same as multiplying this by 1. But we are closing this by changing the sign. From if it is plus, change it to minus. If it is minus, change it to plus. And we are going to get 1 plus very good. So that is what we have there. Here is where we are hoping to be. So you can see the top one is equal to 2 square, which is 1 square minus sine square x. But this is the same as 1. And now, this is multiplying this, okay? So we can go on to distribute that. So here we are going to get, or before that, let's repeat this. Because you have to know clearly that the 1 minus sine square x is cos square. Know that it is cos square. So since the numerator is cos square, so this is cos square x over cos x 1 minus sine x. So you can see that this will cancel one of this, and the final answer is going to be cos x over 1 minus sine x. No, we took it from the right hand side. So we have to go and check the left hand side if it's the same. 20. Even comma is still the same thing. Alright, very good. So that is that. Therefore, saying the right hand side is the same as the left hand side, we can conclude that this equation is an identity. Alright, let me see if I can still add more. Alright, so we are now from question 1 to 4, we are all talking about solving it one side. That is solving it one side. Now, what about if both sides? What if both sides of an identity appear to be equally complex? The identity can be verified by working independently. Take note of that. Can be verified by working independently on the left side and on the right side. So with this, we will not go one side, whether left or right. No, here you go for the left hand side, then after that you go for the right hand side until each side is changed into some common 10 results, into some common 10 results. Alright, very good. So also take note that each step on each side must be reversible. Must be reversible. Alright, so let's try. In fact, with that, we're going to do only one question. We are going to do only one question. So let's try one question for that. See what we have for you. Yeah, so like what I said, with all step reversible, the procedure is as shown in the. We are going to show you the procedure so that when you are given similar, you will be able to also do it as such. Very good. So let me go for that. Wow. Wow. So that's the question, and you can see that both sides appear equally complex. So we verify the identity by changing each side into common 10 expressions, right? And let's first work with the left hand side. From the left hand side, which is sec s plus tan s over sec s minus tan s. Please, just don't cancel this. don't don't go and do anything serious. Here is plus s minus, so it will not cancel out. Very good. So what do we do? What do you think we have to do? Alright, so with this, we are going to quickly multiply it by 1. Alright, but the one that we are going to multiply it by, we are going to make sure that you don't, because when you multiply it by 1, it will not change anything. Now, what to multiply by? We are going to multiply by 1, alright, but it should be in a quotient form, alright, very good. And that is, now watch, sec is the same as 1 over cos. And we also have sec here, which is the same as 1 over cos. We also have tan here, which is sine over cos. Oh wow. And we also have tan here, which is 1 over cos. So this is telling you that for the numerator, when we multiply by cos, it's going to clear off something. And for the denominator, when we multiply by cos, it's going to change. It's going to clear off something because the expression, the denominator for both tan and cos is cos. Okay, getting it. Very good. So for us to multiply it by 1, it is same as multiply it by it's same as multiply it by cos s over cos s. And this don't change anything because it is the same as 1. This cancel this 1. Very good. Very good. So let's move on to do that. Let's move on to do that. So this multiply this, we get sec s cos s plus tan s cos s. All these over sec s cos s minus times S cos S. Beautiful. That's exactly what we have. So that is that. Now what the next thing to do? So this multiply this multiply that multiply that multiply that. Alright, so now we can see clearly here that this will be 1 over cos x times cos x. Now you are getting the reason why you multiply both sides by cos. Very good. Plus sin x over cos x times cos x. Ooh! This is 1 over cos x times cos x minus 1 over, sin x over cos x times cos x. Pyong, 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 pyong. Wow, the beauty of mathematics. And you can see clearly that here, this is going to give us 1 plus sin x over 1 again, minus sin x. Very good. So this is the simplified form. Please, I beg you, when you get here, don't try to be all in all. Don't try to be all knowing that, oh, with this, we can rationalize it again. Hey, pause. Alright. And here, you don't have any goal or weapon on both sides. But you have a goal after expressing one side. Like now that we have this, we are leaving it here to pick the right answer. So our goal now will be to get this. Our goal now for going for the right answer is to be getting this. Very good. So don't just leave it. Very good. So that is that. Let me. That is for left hand side. Very good. So on the right side of the original equation, let's go for that. Allow these tabs. And it's the same thing I'm pushing to you, so that you will also grab the concept too. To get easy. Alright. So let's move on. 1 plus 2 sin x plus sin square x over cos square x. Oh, I don't know if you can remember. I don't know if you can remember from the rules that if you have, let's say, sin square x plus sin x plus 1 is going to be the same as, or you can factorize it. Very good. In the same way, you can see that the numerator here is in the same form, because it's in the same form. Here is 9, so we can factorize it. Right? We can factorize it. So we are going for the factorized form of this. And if you want to get it quickly, take your calculator, put sign to the x. This will be the same as x, let me use a different variable. M squared 1 plus 2m plus m squared. So when you do this on calculator, and if only it was really downward, you are going to get m to be equal to 1 and negative 1. You get only negative 1. And this means that the solution for this quadratic equation is m is equal to negative 1 and m is equal to negative 1, 2. 2, because here we are dealing with quadratic, so we have to get 2 solutions. So this will be the same as m plus 1 whole squared. And we know that m here is sine x. So let's go for that. So this means that this but all right, very good. So now, having this, you can see that cos squared is also the same as it's also the same as 1 minus sine squared. 1 minus sine squared. And don't forget, this is our goal now, right? This is our goal now. And what we have, the one on the numerator, no problem. Please watch, no problem. I'm getting there, but I was still trying to explain it better for you to understand it. Right, wow. So now the numerator, there is no problem there. That is coming from the factorized form of this. But this, from Pythagorean identity, this is the same as the one we have on the denominator. But also this is a difference of 2 squared, because we can square the 1. So sine x plus 1 whole squared, the denominator is going to be the same as 1 minus sine squared x, 1 plus sine squared x. And you can see that one of these will cancel this. And we are going to get sine x plus 1 over 1 minus sine, sorry. When you express it in difference of 2 squared, this will not count. Sorry for that. Thank you. That's why this will cancel one of these. So it will be like 1 minus sine x. Woo! And that is for the right hand side. Now compare. Left hand side, bam. Right hand side, bam. So they are all the same. So this is how we work on both sides. So we conclude that since the left hand side is the same as the right hand side, verifying that the given equation is an identity. So this is an identity. Very good. But I'll give you more questions to solve later on. Very good. But for now, know that you are loved. So I will project questions for you to solve it on your own. Thank you. See you in the next video. What are we going to do for the next video? Let me alert you of it. Okay, I think in the next video we are going to talk about sum and different identities. And we will also talking about co-functional identities and all that. See you in that video. Great! On all that we are doing for you, and if you haven't subscribed to our YouTube channel, then it means you are not helping us. Very good. So go back to YouTube, search Math Experts, and subscribe. Thank you.